All right. It is time for the weekly live stream. Thanks for joining me today. Today we're going to be working at lakes and ponds, sort of a natural outcropping of rivers. Um, Before I get too further, let's thank the patrons. I really appreciate you guys. Thanks for, especially your superheroes and your heroes. Really appreciate it. Without further ado, let's get started. Um, I'm actually in the middle of testing something else. I had just don't remember where I am here. Um, so I had been messing with optimizing some of the fractals, and I, there's one in particular. This abstract cellular sample. I was trying two different versions of this thing that gets the random X. This is one of the core samplers that controls those far plateaus and things. These cellular samplers, there's both the filter and the regular sampler. Anyway, just making simple changes to this turned out to make a lot of difference, and I actually went deep into trying to create lookup tables and so on to maybe speed things up, because it these sign operations tend to be kind of expensive. But as it turns out, it's using sign to get like randomness from the least significant bits. So if you have like a really long decimal, shooting out to 8 or 9 places, by multiplying it up like this and just chopping off the whole number, means that those last little digits were significant. And so anything you do to change that to optimize but create a decent approximation, it destroys all the randomness and everything just looks uniform. So I put it back, but I found that removing these, which hidden division, the modulo operators, it ended up speeding things up a lot. But this one in particular, the one that modulos pi, before passing it the sign, turns out to change the results. And I was testing here to see if the results are bad enough that they would make all my marks invalid, where I've marked places to jump to. So what do we've got? We've got dead end is one of my common test ones, and one of the ones I was specifically going to test this evening. So see, I've still got my dead end here, but it's way further over there, and now this river cuts through here for some reason, and I don't know why it chose to do that. So what I'm going to do for the sake of this live stream, I actually do want to figure out a good way to deal with this situation, but not on the live stream. We're kind of trying to concentrate on ponds and lakes. So what I'm going to do is I'm going to put these percents back. This one, avoiding this %1 to chop the decimal off, doesn't seem to affect the results, but does affect the timing tremendously. So I'll put these percent pies back, and this one too. That should give us the results we're used to, and all my other values will match. Let me make sure I'm actually live streaming. I do that at work a lot, where I'll start talking and realize that I haven't even shared my screen in my day job. So that should do that. And if we just I created this run fractal test, and the base, before I even started this test, would take 33 seconds to run or something. And so we'll see, it's running the map test now. Basically it's generating one of those big giant 16 by 16 kilometer tiles at like 8 meter resolution or something. 2048 by 2048 samples. It's generating that. So it took 25 seconds. So that's still better than 33 or whatever without the change. So, but I was able to get it down to 16 by removing the percent pi. And I will do that eventually. If we want to see what the image it created was, so that's the test it's using. So we've got a bunch of those plateaus up here. The thing is, like, because whatever the change is doing is removing some of the randomness, these are more uniform than right now they're more uniform in height than they turn out to be in the version that just passes the thing on without doing the modulo pi. So it changes the results, but I don't want to change them right now. So that was a long way of saying, let's get started on ponds. And so to do that, let me refresh where we were. Let's run the mapper so we can see where we were. And maybe while that's doing that, I will go over here to the block editor. And so while the map is loading, I will load blocked because I'll show you. I was working on some pond algorithms. Yeah, they're pond only because basically the same for a lake. I just don't have the size in blocked to test anything as big as a lake, but the result is the result is about the same. As I slur my speech there for a second. So let's set the elevation to 5. And let me remove some of the, where's the bit where I offset offset coordinates. We'll turn offset coordinates off, false. And so we'll run this script in the blockhead so I can show you what pond. So execute script. It creates this big round boring pond. If we didn't create the pond, can I turn off the pond? Yeah, false. And did allow the fractal. This creates our that fractal terrain. It's just a more exaggerated version of the fractal terrain I was using to test rivers. And I'm basically placing a pond right here, and I'm seeing what happens when the pond is higher than this valley or lower than this particular cliff. So if we turn the pond back on, a perfectly round pond would look like this. So I've set it up so that if the terrain is significantly above it, it will chop it out, but at a smaller radius to kind of give you these irregular shapes. And this inner radius, as compared to this outer radius, can be tweaked. And so taking the terrain out again, we've got this perfectly round pond, and I added in a fractal offset coordinates true, that will use noise to kind of offset make the pond less round, which is more like a regular pond. And so if you combine that again with the real terrain, then you get something like this, right? So we get some reasonable stuff, and this is what I'm going to work on porting into Java so that we can have some lakes in our lakes and ponds where the rivers end and start, and so on. So this is the area of the land that particular test was generating the fractal for. You see the anyway, the one in particular that I'm looking at, the section I believe is up here. There's this so there's this ridge of cliffs here, and one of these smaller river systems that we cut off. It used to connect to this other one and go all the way to the sea, but in last week's live stream, I put in the code that decides randomly, or I started to, I think I did in the live stream, put in the code that randomly eliminates certain rivers that would be nearly impossible, and changes the randomness and so on. And so that broke this link because it would go through the cliff, and it didn't like that. So So now you get this little stream that starts over here, and that's fine. It's on the other side of this cliff, and you got this one that ends right here. So that was where I was kind of viewing when I loaded the game a second ago. So what we want to do is generate a pond here, or a lake in this case, because that's a significantly wide river that gets to this point. So 10 minutes in, and we're already ready to kind of get started. So what to do first? Well, let's talk about this, right? I can tell because, yeah, so there's actually two different sections of river here. So these are 128 meters apart, I guess. And then this one, probably in the case where we have a really big potential lake pond here, and this these radials of blue are just to indicate like a relative size. I don't know if that's going to be the actual size of the lake. That'll be something we have to tweak, because like this one's really small, and that's kind of ridiculous. But so there may be a multiplier that makes this even bigger than it is. Ideally, you know, it want to like take over this whole area, and that's what I'm talking about here. If we've already determined that a pond would end right here, and we're going to make it this big, we probably want to chop back some of the river, and we might pull that back. But I'm going to look at that when I place the rivers, to sort of look at the immediate area and decide, you know, if there's a bowl already or something. But for now, I think I'm just going to get them into the engine, I think I'm just going to place them wherever this thinks it should go, and make a big, you know, oddly shaped lake pond thing. We'll start small so that we can see it without it getting interfered with all the the mountain range. Okay. So with all that being said, we need to start getting into some code. A river section has like these different parameters: start, end, depth, influence, width. Obviously depth is the depth of the river. It used to be radius, and I changed it to width because it was really hard to have a river that was only 1 block wide, because the radius would be 1, and that would mean it'd be at least like 2 blocks wide, because it'd be, you know, if you set radius to 1, it would have to be at least 2 blocks wide, but it actually turned out wider. It would always be at least 3 blocks. With width, I can set it to 1, and I can let the math down here figure out what to do with the radius. Anyway, so we're gonna do something similar here, and I'm a cut and paste coder from way back, so we'll do, what do we want to call this? Water body, I think is what we'll call it. And I'll start with this so I have something to go on. And we are no longer in 2021. Just a long time ago that I made those rivers. Okay, so all this is still true. Draw, that will carve a pond/lake into the terrain. And we'll call this center. It'll have a depth. It will definitely have an influence. I think it'll definitely have a radius. And there's more parameters than that. Because we have to control, what did I decide? So we have the center radius, influence radius, carve influence. Yeah, these will be good. I was using the same, I was using depth as the carve radius, but that's not really, it doesn't give you very much control. So influence, radius and influence are what controls the actual, you know, border of the radius controls the border of the pond, and the influence controls how far out it will raise or lower terrain to match the border of the pond. There's no algorithm to go back and search the terrain and find out, you know, where the water should flow and all that, because it takes a lot of time. May find out that you still need to raise or lower terrain to make it work, and so on. So we just assume that if we decide to put a pond there, we're going to put a pond there, and we'll terraform the world so that that pond fits. It's massively cheating, but in the end it will actually create more random terrain than what we've got, which is a good thing. And so that's why that algorithm that I was showing you wanted to keep as much of the dramatic terrain as possible. And so then the other one is, so we have the carve radius, which is when I was in here. I'll just run this in the background so we can kind of keep looking at it. Okay, so let's execute the pond. Yeah, so we got, oops. Yeah, so this radius in here was the carve radius, and then the carve influence is sort of how far out we let this carve effect go before just, anyway. Yes, carve influence. There's a blending that happens between, the normal border and, the super carved border. And so that kind of controls that blending. Usually you'd actually make it wider. Like I think it's slightly wider in here. If we look at the pond, got too many files open. I have not cleaned up my files in 3 or 4 weeks of these live streams because we've still been working on the same thing. I'm really looking forward to working on something else. So in this picture I have the radius set to 25. That's, this larger border. The influence radius set to 60, so almost this entire thing. So we raised this valley up to meet the border of the pond. And the carve radius is 5. That's this little bit in here. And the influence radius is, the carve influence is only 8. So that's where, that's what it is. Blending this edge into the terrain. If we set this wider, it's going to make this a smoother canyon instead of a steep canyon. Yes, that's the right word. So if we set that wide and execute it, it's going to, so see, it made this it actually starts inside, that's why. So that lets you control sort of the steepness of the carve. And 8 is what I was using in here just because it was dramatic and I wanted to see. I was really trying to make sure that this part was smooth, how it transitioned to here, because it used to look really ugly. Like you'd see the carve. Anyway. So those are what those parameters do. And this is the code. I'm going to steal a bunch of this in a second. Excuse me. Anyway, I hope everyone else had a good week. I've been a little busy. Unfortunately, not as much time to work on this code as I wanted to. I really want to do caves, except for in fact I almost pushed ponds and lakes off to do caves now, but I started thinking about it, and I've already done caves, and I will definitely do a live stream on that because it's interesting. The similar mechanics to carving, with with respect to caves, keep track of like a line in 3D, and then I'm gonna leave GPT alone right now. Cleans up code in quotation marks. Anyway, for caves and stuff, I already know I have algorithms to lay them out from old Mythruna, and they work just fine. And originally I was thinking, well, I'll need caves in order to properly place towns. And while that's true, it's not like a requirement. Like mining towns would probably be placed near the mountains, and we may not always count on a cave being there. And even if there was a cave that like poked through the surface that a town would be naturally gravitate towards, that doesn't mean that that's where they would necessarily mine either. So it has a limited influence on town placement, and what I'm really trying to get to is town placement and town layout. But I will finish up. I need to finish up rivers, even if I don't get like the smaller river placement done. As far as currently it's 128 meter sections. That's enough to find where towns should be, and so that's really where I'm trying to get to. So yes, I do want to do caves badly, but I think I'm going to continue getting rivers and ponds working, rivers, ponds, lakes working, and then use that to branch off, hopefully next week, into starting to place towns. and get those laid out along a few other live streams. And that'll be cool because that branches into a whole bunch of things, because when you're placing towns, you have to place buildings and NPCs, and we can start thinking about that kind of thing. Okay, so let's get rid of these. We got those. Oh, this is not a river section anymore. This is a water body. But thanks for asking questions. It's always good to know people are around. Okay, so yep, we're just gonna have to. We'll cheat. Actually, I can double cheat. Yep. Watch this. Cut and paste coding at its finest. Oops, I screwed up. At this point, once you screw up enough times, it would have been better just to type it. This partially also makes sure that I hit everything. Whoop. My editor, yeah. My editor, if you hit... Oh yeah, I screwed up. My editor, if you hit Control down or something like that, it grabs the current line you're on, and if you hit Control up or Control down, yeah. There's some way you can capture the current line, and then when you hit Control down, it will insert that line, and that catches me a lot when I'm doing those really repetitive tasks of cut and pasting over and over again. Oops. And for a variety of reasons, actually I think I'll avoid the variety of reasons so I don't talk to them, but because I cut and pasted the river code over from the old the old code I developed a while back, it builds in river data. It builds in its own river section class because the mapper code used to be over in its own thing and not have access to the Mythruna code, and so it created its own little class in here, which really caught me when I changed radius to depth, because I forgot to change this, and I was like, why does the Groovy codes not see depth or width rather? And but we'll avoid that with the water body because we're already over in Mythruna's dependency, and I won't have to create one of these little stub classes and worry about that. Just use the real one. So water body, there we go. And then, because it's an abstract morphology, it's got to implement some things. I think I looked this up for morphology. Let's look up morphology. So morphology in Mythruna, the morphology layers have a chance to modify both the far terrain images that are generated and the individual columns of data, the 32 by 32 chunks, and so they have different methods for different the different contexts. And so in here, oh, you know what? We're going to add one more parameter, and we're going to add int variation. So that'll vary the radius. Maybe that should be the last parameter. Yeah, so we can document that separately. So the variation is what takes, goes from being a purely round pond to, how much variation we put in and out. And I'm just going to call it variation because it's like a radius, but it's not really. It's a x offset and y offset. So then I'm going to steal this method outright, and what we'll do, actually I'm going to what I'm going to do first is just get these into the game in like this, in a, the stupidest way possible, which may just make a big square, to just to get them in, because there's a whole lot of mechanics that we have to do. So results, that's fine. Yep, we'll need the origin, xmin, not to be converted with confused with xmen. All right, so center x, we don't have to do mathmin and all that. Center x minus influence minus origin x, but the range, so let's see, just call this extra for lack of a better word, and I don't want to have to sit and think about it for a minute. Influence plus variation. So this is like the actual radius of influence from the center, the maximum area around the terrain we would ever affect, which is this influence radius plus whatever variation we've decided to add into offsets. Though it could be that by the time we get to the outside influence, we negate any variation. That could very well be true. At the moment, I'm thinking that that would be the worst case, right? You're modifying the terrain in some circle around here, but there may be up to extra variation. So if that's 5, you might vary the border in and out by as much as 5. And so the min of this box that we're trying to decide, what the affected columns are, is going to be the center minus that, and that's all relative. Just, I'll put this in parentheses just to keep it straight. So this is sort of the world space minimum influence of the bounds, and then we're in a particular tile, so we're going to subtract the origin of that tile. And a lot of these then will look similar. Like, I'm just going to cheat and to change this into a Z version, and then the max and the min versions would just add that extra. Right, so that's the range that we affect here. If we see we are even within the, so it checks to make sure. If we're not even in the tile, we won't check anything. And then so in case our pond quite likely will overlap tiles, in case it overlaps tiles, we clamp to the current tile that we're in. We convert those to 32 by 32 grid cells, so the chunks, and that we iterate over those directly, because that just, anything that were there, any of these we intersect, which is what this is checking for, will get added to those IDs will get added to our results. And so the caller will know for a given tile, hey, can you give me all of the, so like, I don't think I have the graphic handy before, but we've in a 1024 by 1024 tiles chopped up into 32 by 32 tiles, and we're basically saying which of the 32 by 32 tiles are affected by this particular body of water, and that will be used when when we are actually rendering the chunks and things to decide, this chunk actually needs to be modified. Okay, so we've got that. That'll tell us the affected columns. The morph, we're going to cheat for a second. Let's see, we probably do a similar thing. We're going to need all of this information. I'll explain what it is, but we're going to need the same xmin, ymin garbage. Okay, so this is when we morph a tile. A tile is a 1024 by 1024 section of the world, and it's got, this is actually part of Moss, the open source parts. It's actually got multiple layers in there, and you can actually define your own layers. But the ones that it defines by default are like the terrain layer, and it may be multiple resolutions. So, for the really far terrain, it's like at the lowest resolution, it samples at 8 meters or something. Every 8 meters is a pixel kind of thing. So we grab that because we want to generate the pond even into the far terrain when it's first generated. And we get our tile ID. We're going to need that in the origin. We're going to need that for the same reasons we needed it up here. So we'll figure out what our min and max is. We're going to want to, we might be outside of our own tile. I mean, might be a border lag, so we're going to need that too. And I think I did all that here. This one, it's interesting. This one kind of did it all in one, and then doesn't check for min and max. So anyway, I'm not going to worry about that. We will do that. We will steal these loops though. So did I close I closed blockhead, didn't I? Yeah. What it does is like oh no. Yeah, okay, so I gotta finish making this return. Also I have to at least get it to compile. Oops. How the algorithm works is you'd think is, oh, we've got a pond, we're going to start from the center and we're going to draw water out. But that's not the way it works. It goes over the entire grid of influence. So if we go to generate the pond, it's so there's terrain generated and so on. It decides, this big square is what could possibly be influenced by the pond. So I'm going to start here and I'm going to say how far away am I from the center? Okay, is that less than the influence radius? No, it's actually farther. So maybe down here we're starting to, so here we're starting to get into the influence radius. So as I'm iterating over all of these samples, I'm saying how far away am I from the center? Oh, we're in the influence radius. Okay, let's get the regular terrain height and figure out how far we are from the radius, and that's how much influence we should have. Are we less than the radius of the pond? If so, then we've got to put water there, and here's how deep we should be, and so on. And that's what we are going to be doing here. We're going to be iterating over every point, and we're going to skip whatever this particular resolution says we should skip. In the high resolution, that's 1, because we're going to hit every pixel, but in the far resolution it's 8 or 4 or 16. I can't remember. Well, we could look. I don't have to guess. We've got up here terrain dB tile ID. I think is it resolution and tile resolution. So the 3 resolutions you have are high, which is a 1 to 1, medium, which is 1 to 8, and low, which is 1 to 16. So we skip every 16 pixels in low resolution. And it turned out that's why and then actually when you're registering morphology, different layers and functions that operate on those layers, you can say what resolution they apply to. And by default, if you don't specify one, it'll apply to all of them. And I had specifically put the river stuff only in the highest resolution, and I was worried at one point about the far terrain wasn't rendering the rivers unless you actually went there, because then it would render the high res rivers, and as you went farther away, then they'd be in the low res, because whenever it renders a high res, it pushes all those changes down to the lower resolutions. But this was why, is because I had only registered it for high, and so I took that out. And sure enough, it generated rivers in the far tiles just like it was supposed to. It was one of the easier bugs I found over this past week. It's kind of nice. So anyway, starting from the min that we've clamped to this particular tile and going to the max, we'll do this, and we'll just do something dumb and say, gosh, let's steal the code that gets the current elevation. We don't actually have to do anything smarter. Rivers are hard because rivers are a line, and so instead of here we can just say, hey, what's the distance to the center? With the river you had to say, what's the different distance to this line? And so at the top here, that's what this algorithm is. It's basically doing a point to line, but line segment, which is even trickier calculation to define how far we are away from that line squared. We don't have to worry too much about that here, and we'll just make a round river for now. So what we will do is we will say dx equals, so that's our x minus, can't think, center x minus origin x. So our x, which is in tile space, because we've made it tile space up here, and then, oh, you know, I bet that's what the other code was doing, was not putting it in tile space. That's probably why. It was leaving it in world space so it didn't have to do this calculation every time. But anyway, I wanted to cut and paste the code, so we'll do that, and just means we have to subtract back out origin. So our center x, which is in world space, we will put it in tile space, and we will see what's the distance in x. What's the difference? Excuse me. What's the distance in x? What's the distance in z? And good old Pythagoras, who didn't believe in fractions, but certainly gave us a lot of other stuff. Or didn't believe in, fractions, I think is what it was. Believed everything should, well, maybe it's ratios he believed in, and irrational numbers he didn't believe in, or something like that. But anyway, but then square root of 2 gave him a lot of problems because that's an irrational number. Blah blah blah. Look it up in the history if you have no idea what I'm talking about. It's quite interesting. Okay, so train get elevation though I think is 0 based. So let me x min. No, we put it in tile space. So yeah, we're doing basically the same thing here. Yeah. Here we got. Okay. Distance squared. It's interesting. Yeah, so x relative local start. Yeah, okay. The rivers are just different. This is going to be way simpler because if d squared is less than radius times radius, then we'll do our magic, which is for right now. We will. What do we want to do? I think probably we didn't need to grab the terrain elevation. We will just set train set elevation x comma z river section. Where do we set the set elevation? Yeah. We'll leave the type the same. Terrain has these terrain image layers have basically two attributes. One is the type of the terrain on that particular location, and the other is the elevation. And even fluid or regular terrain, they both have this. And so if we set at that particular elevation, we set it to like 10. That will be way below any terrain we have. It'll be crazy pond lake. And then in fluid, we set the elevation to whatever our level is going to be, which should be center.y if the pond is set up correctly. And then we'll set the type as water. It's the only type that we really render at the moment. Okay, so that would be enough to get it into the near/far terrain, and that may be enough to test with. Let's make sure we compile. I can probably close this guy finally. All right, and there was another trick I did with rivers. That's that I created this. Where's the, river section protocol. We will need that for sure. We need one for water bodies. For now, I'm going to ignore storing it, which will create problems for us later. But I think I created a temporary river file tile function. Yeah, that's this. I must have set the JSON up right in there, so we'll just copy paste this water body file tile function. Oops. So this is the one, like basically I hacked that mapper tool to store a bunch of JSON for the rivers. Like you can look in more, what's it? Whoa. More 123 rivers.json. So you can see it stores all the rivers that the mapper tool generates as JSON. That's not how it works in the real game, but right now we're just trying to see it in the game. So the mapper tool will generate those and dump them to disk. And then there's this river tile function that would load them up, and then we're going to change this to a water body tile. Whoops. Whoop. Water body should be file tile function. That's a weird name. Yes, this is just a temporary thing to get them into the game until I can do basically port all that generation code over to Mythruna itself. But you know, that doesn't make for interesting live stream content. So this wants to know if we even intersect a particular tile. Yeah, in fact, water body, water, and let's do ourselves a favor. First of all, we never added getters for all of the stuff. And for now, I'm just going to cheat, and I'm going to add these that basically do what we did here. Perhaps a little differently though. We will return new vec3i center.x. Oh, let's do this. This was convenient. Center.x minus extra. So it's the min. It's going to be center.y minus depth. And center.z minus extra. So that's the min. We'll cut and paste coding. And this is the max. That way we don't have to do that math everywhere we want to get. Oh, we don't need it. It's just max is going to be the center. Yeah. Oh, except for it's not. It's going to potentially be, I mean, that's fine. It's going to affect more terrain than that, but we never care about the Y value in these. We could have just left it center, center. In fact, so making sure that we don't rely on it for anything else. So that makes this easy because we can just say section or water get min and water get max. So does this particular body of water even intersect this tile? Just making sure we're not doing anything else there. So we get the start, we clone it. Oh, we max local with the end. Yeah, so that's, we don't have to do that in this case. And we don't have to do that because we've already included the influence. And so, yeah, if max x is less than tile, yeah, so this is just checking the box to see if this box intersects the box of the tile. So, morphology layer, yes. And so in here, instead of river section, we want, in fact, let's do this. Water body, and we'll change section to water, waters. So let's, yeah. I can't stand it when things look stupid like that. So anyway, so we'll go through all the bodies of water. Check to see if they intersect, excuse me, this tile at all, and then we'll add the water to the tile. So that should work. And wherever we've registered this, in the world manager, which controls all of the stuff that's, added. Yeah, you know what? We're gonna have to add the protocol. Okay, for the moment, yeah, for the moment we'll regenerate them every time. Otherwise it's going to try to load and save them from disk. And here we'll add, I believe we will want to make sure we're doing the water body file tile function first. I think we want to generate the bodies of water first so that the rivers can flow into them naturally and not have like weird rivers floating in space. So apply morphology is still the same. And somewhere, yeah, okay, so that's the load function. Somewhere we save it to. Maybe it's after everything. Morph db get save function. So temporarily put this back. And a lot of times as I get out of the live stream and I forget kind of the temporary hacks I made to get things done in the live stream. I don't normally code that way, but I kind of try to keep things short. But we want to get these in at least tonight a little bit, right? And we've got 13 minutes left on the normal time. So does this compile? So I get antsy, right? I try to think of shortcuts and it ends up biting me later. And if I'd had more time this week, I would have done this part first, then we could have worked on the algorithms, because that would have been nice to do the river valleys as well, because the influence thing is very similar. Okay, so that all compiled. Now we need to actually build these and save them, which is part of the mapper tool, right? We've got all these set up. And then where we draw the rivers, I also want to make, okay, so let's run the mapper tool. We're getting close. We might make it. I'm not going to make famous last words by promising that I'll show something before I stop, but it would be nice if we could get some visual in the game to show that we're on the right track. And if you guys are listening to this now and are not in the Discord, please join the Discord. I frequently post progress images there that don't necessarily make it to Twitter or other places. I should really get better about posting things to Instagram, but there's so many social media outlets that it's kind of hard to keep track of all of them. And Twitter's like my quote-unquote daily driver, despite the upheaval it's been going through lately. And I'm in Discord all the time, so 24 hours a day. What are we doing? Oh yes, so I'm just going to come over here and look at this. So we've kind of created a radius for these, and I'm going to steal that when we generate the rivers. And we'll go back up here. I think, where are we adding this? Yeah, so river sections, where did I find that? We'll do something similar for water bodies. Let's make sure I haven't already created a water bodies. Okay, should be okay then. Okay, what are we doing here? So we added a river section. We added a river section here, but where we want to add the bodies of water. Oh, thanks. Good. It just it's like, using you guys as my rubber ducks, but also like posting some cool pictures that I don't want to spam to Twitter. I try to only post the very coolest things to Twitter, or things that are marketable, I guess. So somewhere in here, I'm drawing these little stars, and probably if I search for cyan. Ooh, no. How did I... There's going to be a little loop where I loop over those 8. Yeah, here it is. So in here where I added these little pond dooley-doos, water bodies dot add new water body, and the center will be I think if I do V floor, V is the location in the world where we were rendering this little guy, so that thing right there. And floor is one of the methods on the vec3d class, which is double xyz, and floor will turn it into an int by chopping off the vec3i, which is the integer version of a vector xyz. We'll chop off the decimal place, basically, decimal portion. Radius, actually, you know what? It's not going to let me do this. I have to know river section, water body. I just have to remember, so I'm going to cut and paste a reference for the minute. Okay, so depth we ignore. I'll make it 5 for now. Influence, we'll make it, we're ignoring that too, but we will make it 2 times the radius for now. Oh wait, we needed radius first. R times 2. I call that pond size. Pond size times 2. That's the influence. Carve radius will make 10 ridiculous. 15 for the carve influence, and variation we're not doing right now, but we'll make it 5. And so we're adding these. See if it, yeah, it doesn't like it. What did I do wrong? My neighbor's rod class water body. Are we not importing? Where did I put water body? River. And I have to be careful, because if I suck in that suck in the river section, I create a confusion for myself. River water body. So we'll do that without the star. Water bod. Okay, so that should do that. Okay. Somebody's unhappy. Water body vec3i integer double. Oops, double. Pond size. That's good. Okay, we're good. We've added them. We haven't written them anywhere. That's the next step. So we'll do the same thing for test file ponds. We'll call it ponds, even though it's going to be ridiculous. We could use our same JSON text equals JSON to JSON water bodies. I really like JSON. It's really convenient. And so we ought to be able to go more 1, 2, 3. Oops, that's right. 4, 1, 2, 3 ponds. Yep, so ponds. Oh, look at that. We got ponds. Center, depth, radius, influence, blah, blah, blah. And so we've got those saved. Okay, so now I just need to make sure. I'm quite sure that I did not use the correct file name when I added this to the world manager, because I cut and pasted the, yeah, so I'm not using the right file. Test file 2, ponds, test file 1, test file 2. It's backwards, but it'll work. Okay, so I need to make sure my data is all cleaned up, and we ought to be able to go in and see what other bug I missed. Now, when we get in, the local terrain will not have a pond because we're not modifying the chunks yet. Gosh, I hate that word, but it is a good word. I just hate it because everybody thinks Minecraft when they hear chunks, but the column data is, you know, the 32 by 32 sections of the world. We're not modifying that. We're only modifying the far terrain. So I could probably just turn off. Yeah, this always takes a long time to load. You get to hear my lovely voice while that happens in the suspenseful loading music using the Mythruna theme, which came to me that very first few months that I was working on the game and has stuck with me. Of course, this is the, you know, suspenseful version. Okay, we're almost there. We're coming. It's coming. It's got that plateau terrain always takes so long to generate, otherwise we'd be in by now. Where are we? Oh yeah. We're at the bottom of the, no, that's right. If you modify the if you modify the terrain image, that's what it uses to generate the column data. So we actually did get a big giant pond here. That's cool. I mean, it's ridiculous, right? Yeah, the big old river that cuts through. What the hell is this? Okay, guys. Why do we get like this one weird slot over here? Anyway, while it finishes loading in the rest of the train, you can see up here we've got, you know, tons of things queued while it's generating some of this far terrain. That's another thing I need to figure out. This the low workers are the things that are generating the far terrain. That's what these guys down here are, these, you know, far terrain segments. And then this is the stuff that's trying to generate the terrain around, right immediately around me. And there's some kind of lock that happens where at least 4 of these guys get stuck waiting for 1 or more of these guys to complete, which is fine, except that means that these low priority threads, which there's only 2 of, are holding up the higher priority threads, which there's 4 of. And so I'd like to, at some point in the future, look at removing that kind of quote-unquote deadlock. What do we got here? Uh-oh. Yeah, so somebody failed. Yeah. There's somebody trying to write to, yeah, we actually lost the, Java has this option where it eats the exceptions if they've seen a lot of them, and there's an option you can give it to, yeah, so, to get elevation, anyway, apparently our XY for, let's see if I mark this so that it'll stop scrolling. Get elevation, so the water body is apparently trying to get elevation outside of its outside of the tile, so there's something wrong with the code we use to calculate min-max, that means that this is going to fail in a significant number of cases that we'd want to see, but it's working. I have no idea why it leaves this strip behind. It's kind of interesting. And obviously because we created these vertical walls, the far terrain doesn't like that very much, which is one of the reasons we give them a little bit of a slope. The far terrain doesn't do much with, yeah, see, I'm actually bouncing on the far terrain right now because we're blocked. Oops. But actually, that was a surprise. I forgot. When we generate a high-res tile, that is what's used as the basis fractal for when we generate the real world data. And I forgot about this because the river generator actually goes back and does additional work when generating column data, because when the far terrain is generated, the big 1024 by 1024 tiles, it just kind of roughs in the elevations of the river water. And then when we generate the actual 32 by 32 sections of the world that actually have the Mythruna blocks in them, then I need to know actual water height and smooth water from one end of the river to another. This is really bizarre that it's got this. I wonder. So usually when I see something like this, and you guys probably can't see, I always forget that YouTube is going to darken everything. Okay, so yeah, we're still waiting for things to generate. We got 966 going. Okay, so things should start going pretty quickly here soon. Boy, some of that far terrain is really, wow. We're still adding things. I'm just looking at the queues here. That queued count was still going up. We were still adding things. I believe that all those crashed tile generations have put us in a weird state. Yeah, we're getting more and more as we go. But one of the first things I usually look at is I turn on the grids that'll show the 32 by 30. Yeah, so that's right along a grid boundary. So probably that same thing that's causing data to overwrite the border is the same thing that let this little sliver of terrain in right at the beginning of this tile. I think it's the beginning. Let's look at the map. Oh, it won't have generated the map. Oh, yeah. So we're looking directly west. So this is actually... That's actually the top of that tile. This is the bottom of that. So, because this is north. No, that's south. Yeah, so Z grows in this direction. So this is 0 and this is 32. And we are probably right on a tile border. If we watch these tile numbers change, I can see, yep. So you see this was minus 7168 up here in the corner. That's the origin of this tile that we're in. And if I move over just slightly, boink, now we're in a different tile, minus 8192. Actually, you can see it right here too, right? We're inside this tile now, and we're inside, well, you can't see it there, but we're inside this tile now. And so that's a bug at the tile border, and I just believe that probably, I think actually the far terrain to walk around on kind of looks cool. It's not right for the game, but just considering that it shouldn't work at all, I just find it amazing that even without any of the blocks, you could make a game out of this. I mean, it's more like a 1990s game maybe, but it works. So that's a impressive piece of kit. All right. So I think I don't know if we really want to go into me doing bug tracking, but we got a pond in. It's ginormous, right? And cut right into our mountain, and that's what I wanted to avoid. So the real algorithm, the one that's used in Blockhead, because we've got this other river source that starts here on the other side of that cliff that's gone now. We're seeing just a little bit of the chopped up cliff over here. So this is kind of cool. It's working. and now I can just fine tune it. If there's a large demand, I could continue this live stream, tomorrow night, with whatever progress I've made during the day and or Sunday. Um, if anybody's interested in seeing, actual progress other than just putting a big, ugly blot into the world, just let me know or respond to the video, and so on. Anyway, so we made progress, and I'm like, this is perfect because you guys have helped me get excited about working on this, because the foundation is in. Now I can fix some bugs, work on the algorithms, get the river valleys and pond/lake valleys working, and move on with my life. I do still need to integrate all that stuff into the engine itself, so we don't have to run the mapper tool to generate this stuff. But this is good enough for getting to towns and things and working on the algorithms, so it's kind of cool. All right, I'm gonna just exit out for now. Yeah, because I don't think those, we've got now 1,000 of them. So yes, something's in a loop, constantly re-adding those tiles to be generated. And so I'll go in here and go ahead and set the thank you page. If there are any last minute questions, feel free to ask. But otherwise, I'm sort of in the wrap up phase here. We're 6 minutes after the hour. And thanks for watching. Like, comment, subscribe. Share with your friends. If you think somebody else is interested in world generation or might like Mythruna or just whatever, share with your friends. If you already have the link to the download page, you can feel free to share that with your friends. It's only pseudo secret at this point because I had it in the background of a video, and I've been meaning to put it in the background of every video, but we'll get there eventually. I'll remember to do it. Just leave it kind of up in the corner up here, so if anybody wanted to grab it, they could. But yes, if you have friends who want to try it and who haven't been following the channel, they're welcome to hit that download page, and you can give them the password. That's not super secret anymore. I want to limit the users to the people who are kind of into it and willing to have a conversation about problems they find, rather than just complain on a forum somewhere. They're willing to talk to me about it. But hopefully I'm trying to get to something in June that I can release publicly, because that'd be the 13-year anniversary of the last public release. But we'll see. To be honest, I wanted to be here last year, and so we'll see. But anyway, thanks for joining, everyone. Whoever was on live with me, thanks for hanging out. To those of you who just watch this later, thanks for watching, and I will see you guys next time.